All right, so apologies for the technical glitch. Continuing with the class. Now, so far we have studied magnetic flux, which is given by phi b equals to b dot del s. Second, we understood what was electromagnetic induction, which basically says that when you change magnetic flux, then you will get induced EMF and induced current. Third is Faraday's experiment. 3 experiments we have understood by diagram also, by simulation also. Then we learned about Faraday's laws, first law and second law. First law is basically the definition of electromagnetic induction, that when you change the magnetic flux associated with any coil, then electric current is induced. And there is a second law also, which is very important for us, and which says that the induced EMF E equals to minus N d phi by b by dt. Then why this negative sign appears? The answer of that lies in this topic, which is Lenz's law. Now we will try to figure out what Lenz's law is. What Lenz's law is, we will try to figure out. So, to understand Lenz's law, first we need to know about a rule called the clock rule. What does clock rule says? It says that if you have a circular coil in which current is flowing in anti-clockwise direction, then this particular phase will become north pole. It will acquire north polarity, and that other side will acquire of course south polarity. Similarly, if in a circular coil current is flowing in clockwise direction, then this phase will acquire south polarity and the other one will acquire north polarity. So that's basically clock rule, because we know that whenever current flows through any coil, then it generates magnetic field. So if it generates magnetic field, that magnetic field will have a direction from north pole to south pole. That means there must exist north pole and south pole, which is given by this simple rule: current anti-clockwise north pole, current clockwise south pole. Now, understanding that, we are good to go with Lenz's law. So in Lenz's law, what we do? We take a coil, we take a magnet. This is north pole, this is south pole. So now remember, in Faraday's experiments, when the magnet was moved, electric current was induced. You will notice that when this north pole of the magnet is taken closer to the coil, the direction of induced current here is anti-clockwise. Anti-clockwise means which polarity it will acquire? North polarity. So that means this phase will acquire north polarity. Now go back to the definition of Lenz's law. What Lenz's law says? It says that the direction of induced current is such that it opposes the change in magnetic flux responsible for its production. So it will basically oppose the change in magnetic flux. Now when you are taking this magnet towards the coil, what is causing the change in magnetic flux? Approach of the north pole of the magnet towards the coil. And what is the polarity acquired by the circular loop? It is north polarity. So this is also north pole, this is also north polarity. So what kind of force will exist between them? Of course, alike poles. That means the force will be repulsive. That means there will be repulsive force between the magnet and the coil. Now go back to the fact that you are changing the magnetic flux by taking this magnet towards the coil, and the direction of the current is such that it is repelling the magnet. That means it is not letting the magnet come towards it. But still, if you want to move this magnet towards the coil, you have to do work done. And that work done is basically transformed into electrical energy. As a result, you get electric current in this coil. So electromagnetic induction is no magic, my friends. It is basically transformation of energy. The work done you do to bring this magnet closer to the coil is basically getting transformed into electrical energy. As a result, you are getting induced current in the coil. That's basically Lenz's law. And what happens other way around? Let's see what happens other way around. So I just remove this also. Okay, so consider this to be the magnet. Now remember, if you take the magnet closer to the coil or away from the coil, in both the cases we are getting induced current. Now taking closer, we have seen, if you take this magnet away from the coil, then the direction of current here is clockwise. And if the direction of clockwise, then this polarity is of course south polarity. So this polarity is south polarity. So what is happening here? You are taking the north pole away, and as a result south polarity happens. And what kind of force shall exist between a north pole and a south pole? Of course attractive force. So this coil, the direction of induced current in this coil is such that it is not letting you take the magnet away from the coil. And if you still want to take it away, you have to do work done, and that work done is basically transformed into electrical energy. So from this we conclude by saying that Lenz's law, it obeys law of conservation of energy. Electromagnetic induction is no magic but simple physics. Next, moving on, we will try to figure out what we have learned by looking at a simulation. So see, this is the setup for Faraday's law. What was Faraday's law? That whenever you change the magnetic flux associated with a coil, then electric current is induced. So you take this magnet,